So let's continue with the fifth examples on the areas of the similar triangle. Okay, in this question, we are given that there is a triangle ABC. This is a triangle ABC and DEF. This is D, this is E, and this is F are the midpoints of the side AB, BC, and AC. And we are going to join these midpoints. Okay, and what we have to find? We have to find the ratio of the area of triangle DEF upon the triangle ABC. Okay, so we are given that D, E, and F are the midpoints. Okay, so from midpoints we have to utilize this fact. Okay, the one thing which strikes me after listening midpoints is midpoint theorem. So midpoint theorem. So let's apply midpoint theorem. Okay, so what is midpoint theorem? A line joining the midpoints, of two sides of a triangle is parallel to the third side. Okay, so this is the case. DE is parallel to AC. Similarly, these are also the midpoints, so EF will be parallel to AB and DF will be parallel to BC. So if you look very closely in the diagram in the diagram DFEB, if you look at this, then we can say that this side is parallel to this side and this side is parallel to this side. Hence, DFEB is a parallelogram. We can say this? Yeah, of course we can say this. So in a parallelogram, opposite angles are equal. So if this angle is 1, then this angle will also be 1. Now in this diagram there are many parallelograms. So if we look more closely, let's use some different color. This is also a parallelogram. D, F, C and E. This also forms a parallelogram. Okay, again by midpoint theorem. So what we can say is, if this angle is 2, because in a parallelogram opposite angles are equal, so this is also 2. Hence, by AA similarity, we can say what we got from here: angle B was equal to angle F, both equal to, we have named them as 1, both equal to angle 1, and angle D, I should take here C. Angle C is equal to angle D, which is equal to angle 2. We have named these angles as angle 2. So by AA similarity, which triangles will be similar? Triangle BAC is similar to triangle B was equal to F. So triangle F, E and C was equal to D. So here D. So these two triangles are similar. and again now they are similar, then the ratio of the areas of similar triangles, triangle, what is this, triangle FED and triangle BAC is equal to the square of their corresponding sides. So let's take a side, corresponding side. Here we will take AC. So no, upper side smaller triangle, so this. So we will take ED upon AC whole square. Okay, so where is AC? This is AC. And where is ED? This is ED. So let's use some color. This is AC and this is ED. Yeah, so again we have to represent these two terms in some common terms. So let's try to find a relation between AC and ED. So our next step is finding relation between AC and ED. So is there any relation between AC and ED? Yeah, of course. As we have already said that this forms a parallelogram. Yeah, this forms a parallelogram. A, D, E, F forms a parallelogram. And in parallelogram, opposite sides are equal. This side is equal to this side. And as F is the midpoint, so FC is also equal to AF. So all these three are equal. DE is equal to AF is equal to FC because F is midpoint and these two are equals. This and this are equal because they form a parallelogram. Okay. So from the diagram, looking at the diagram, we can say ED upon, instead of AC, we can write 2 times of AF. Yeah, we can write this whole square, and AF is equal to ED. So in the next step, we will write ED upon 2 times, instead of AF, we will write ED whole square, which comes 1/4. This is the final answer.